Hi team, welcome to Wiggins Maths. In this video we're going to look at our second type of proof. This is proof by deduction. Now this is the most likely proof that you'll be asked to use in your exam other than proving differentiation from first principles. Okay, so what exactly is proof by deduction? Okay, it's all about taking facts that we already know and using them to help us prove a statement to be true. So, for example, if a and b are positive odd integers, then a add b is even. So there's not a finite number of things that we can substitute in, like with exhaustion. So we need to think about a different way of going about this. So odd. So let's say that a is 2n add 1, and b, we can't use n again, we have to represent it using something else. So we're going to go for n add 1, and we can say that n and m are integers. Okay, so we've represented a and b as odd numbers using these variables n and m. Now if we add those two together, we're going to get 2n add 2n add 2. And hopefully you can see now I can take a factor of 2 out. I've successfully shown that this is true. And this is called deductive proof or proof by deduction. Okay, now that's just one type of problem with proof by deduction. Here's another one. Okay, so if we have a quadratic and we're told there are no real roots, really important hint there, prove that this is true. So no real roots, we should recognize that that is related to the discriminant being less than 0. Now, if that's the case, then we can find out the value of the discriminant or an expression for the discriminant from this. So we've got negative 5k squared, subtract 4 lots of k, lots of 2, and we want that to be less than 0. So that's 25k squared, subtract 8k is less than 0, and we can factorize this expression. Now, I always tell my students to do a little sketch of this quadratic here. Well, the roots are going to be at k equals 0 and k equals 8 over 25. We know the shape of a quadratic, so we're trying to find, therefore, the inequality that represents this. So that is going to be 0 is less than k is less than 8 over 25, which you might think has proven it. Oh dear, this is a slight problem, isn't it? We're not far off, but we haven't quite proven it. And the way that we show that it could be equal to 0 is very simple. If we were to substitute k equals 0 into here, we'd end up with 2 equals 0, which is definitely a contradicting statement. We'd have to show this line of working, but then it is enough to then add that in. Okay, so we have successfully proven that this, when it has no real roots, gives us this inequality here. Okay. And the third type of problem, prove that this quadratic is positive for all y. Now there are lots of different ways of doing this. Okay, I'm going to do this by completing the square. So I'm going to take a factor of 3 out of those first two terms. You could take it out of the whole thing, but I feel this is a little bit easier to deal with. Okay. So it's going to be 2/3 squared. And add 10. And then we're going to tidy this up slightly. So 3 lots of y subtract 2/3 squared. 3 lots of 4 ninths. So 3 lots of 4/9 is 4/3. Add 10 is 34/3. Okay. And something squared is always greater than or equal to 0. So 3 lots of that is always greater than or equal to 0. And then we're going to be adding something positive. So therefore, that must be positive for all values of y. And therefore, we have proven that by deduction, a deductive proof, using facts that we already know. Okay, as always, by watching this video doesn't instantly mean you'll be able to do it. There are lots and lots of different types of questions where you'll be expected to prove by deduction. It is just a case of practicing. And the more you practice, the better you will become. And of course, amateurs call it genius, masters call it practice.